So this third worksheet is a huge part of the midterm, Mario. Huge part of the midterm, okay? Now, there's some where they ask you to graph, so I'm tackling the graphing one by giving you a graph. But if we take a look at number 1, and this is probably the one that's going to take the most effort by you guys to finish this worksheet. Take a look at number 1. Where's the line x plus 3y equals 3? It's right here. X plus 3y equals 3 is this line right here. Yeah. And the other one they want is x plus y equals negative 3. X plus y equals negative 3 is the one on the bottom. So if you're looking at this one and this one, where do they intersect? Right here at that point. That's the coordinate, what? Negative 1, 2. Negative 6, 3. Correct?
Yes.
And that's your answer for that system. Okay? So when it's visual, it's easy. All you're looking for is a point of intersection. What if the lines do not cross? There is no solution. But what if you graph the lines and it's the same exact line? There's infinitely many solutions. Okay? So you will get a couple of those. As a matter of fact, let's jump to one of those. Like, look at number 4. It says 4x minus 2y equals negative 6. That's this line right here. And if you look at the other equation, it says 2x minus y equals negative 3. It's the same line. So number 4 should be infinitely many solutions for number 4. Infinitely many solutions. IMS, I'm just going to say, for number 4. That would be classifying the system, but we're not even going to classify. It doesn't come out on the midterm. So the only thing on the midterm is, could you find the answer? It might be infinitely many solutions, might be no solution if they're parallel. Let's actually solve some of these systems. Like number 6, it says solve with any method you like. Number 6, it's ready to rock. If you combine the lines, x plus x is 2x. Negative y and a positive y cancel out. 1 minus 9 is negative 8. So you end up with a one variable equation, one step equation. All you got to do is divide by 2, and you get your answer, x equals negative 4. Once you have one answer, what do? Plug it in. You can plug it in any one you want. I want to go for the top one, plug in a 4 right there. It's going to say negative 4 minus y equals 1. And if you solve for y, plus 4, negative y equals 5, which means y equals negative 5. So if you want to write that answer as a coordinate, it should be negative 4, negative 5. Now if you go back and plug in negative 4 for x and negative 5 for y, it'll give you a true statement. Plug in negative 4 and negative 5, it'll give you a true statement. That's the way to double check it. Now that one was way too easy. Sometimes you'll have to modify one equation, sometimes you have to modify both equations of the system to get something to cancel. Sometimes you might want to use a different method. Like on number 7, substitution is a great method, because the second equation has y by itself. Now you could use linear combinations, the elimination method, but you first have to rewrite this in standard form, the ax plus by equals c, in order to be able to line up the x's, the y's, the equal signs, and the numbers. So you might want to use substitution. Substitution is where you take the binomial that the letter is equal to, in this case y, and plug in that binomial, substitute it into the y. So in other words, you're going to have 3x plus y, but instead of y you put parentheses, equals 12. Now inside those parentheses you're going to plug in the negative x minus 2 inside the parentheses. Now notice that there is nothing to distribute out here. There is no minus sign, there is no number, it's a plus sign. If you distribute a plus, nothing changes. So you will have the simple 3x minus 2 without parentheses equals 12, because there's nothing to distribute outside the parentheses. After that, you combine the 3x take away x, you will get 2x minus 2 equals 12. And then you solve. So if you add 2 to both sides, you're going to end up with 2x equals 14. And if you divide by 2 on both sides, you'll get x equals 7. That's one answer. You need the other. What do? Plug it in. So I'm going to take the 7 and plug it in right there into the x. So when I plug it in, it's going to be y equals negative x minus 2. But in there, I'm going to plug in the 7 right in there. So it's going to be negative 7 minus 2. Y equals negative 9. So my xy value, my answer, my coordinate is 7 comma negative 9. And of course, if I had time, I could go back and double check it. So right here I use substitution method, which is great only when you have a letter already by itself. Now you could have done linear combinations method if you wanted to. And there's going to be some where you have to modify one equation. Sometimes you have to modify both equations. Like right here, this guy, it's not ready to combine and cancel. You're going to have to change one of the equations. So you'd probably change either the top or the bottom by multiplying it by negative 1. So that this could become a negative 2x, a negative 2y, and a negative 6. That way the positive 2x and the negative 2x cancel out. I think that one's too easy to go over. How about we try one where we have to modify both equations? Let's say number 10, for example. No, that doesn't work. You could get away with 1. How about 13? 13, let's get something to cancel. Do you want x's or y's to cancel? Okay, y's, just to let you know, when I decide to cancel out y's, this is going to have to become a negative 42. This is going to have to become a positive 42, right? I'm going to have to multiply the whole thing by 7 and the whole bottom one by 6. Wouldn't it be a little nicer to multiply smaller numbers like 3 and negative 4 instead of 6 and 7? So let's go with the x's, yeah? Let's cancel out x's by multiplying the top equation by positive 4 and multiplying the bottom equation by positive 3. So when we multiply the top equation by positive 4, we're going to end up with 12 minus 24y equals 36. And the bottom one, you're going to end up with negative 12. Oh, I'm sorry, I forgot the x. Yeah. Negative 12x plus 21y equals negative 48. And now we're ready to combine and cancel. You're going to get negative 3y equals negative 12. And that's a single variable equation. So we're going to divide both sides by negative 3. You're going to have y equals positive 4 as an answer. You have one answer, you need the other. Let's plug it into the top one. We're going to have 3x minus 6y, but instead of y, I'm going to put that 4 in there, equals 9. So you really have 3x minus 24 equals 9. If you add 24 to both sides, you end up with 33. So you have 3x equals 33, which means that x equals 11. So your final answer will be the coordinate 11, 4. 11, comma 4. Check out number 14. That's a special case right there. When you decide to cancel out x's or y's, which one would you say? X's or y's?
X, because they're bigger numbers.
Let's cancel out y's by multiplying by 3. That way the positive y down here will become 3y, which will cancel with the negative 3y. So the top one we're going to leave the same. 12x minus 3y equals negative 9. The bottom one's going to change to negative 12x positive 3y equals positive 9. And guess what happens? Everything cancels out. You have 0 equals 0. Now 0 equals 0 is always true. So what do we say? So that's your answer for number 14, infinitely many solutions. Now, ladies and gentlemen, if you're working on a problem and the x's and the y's cancel, but over here the numbers don't cancel, let's say you had a 0 equals 8 or 0 equals 1, then you would say no solution, just to let you know. I don't know, I guess we have some time for one or two more. Is there anyone you'd like to see, or you just want more time to work on it? Number 9. So, number 9, you could use substitution if you like. Or you could rearrange it so it could be in standard form, so you could use linear combinations. What do you guys say? Oh, is that? Substitution, okay, so let's take the 2x plus 6 and plug it into the y value right in there. So I'm going to rewrite the bottom equation, 2x minus y, but I'm going to put parentheses, equals 2. Now inside those parentheses, I'm going to plug in the 2x plus 6. Notice that there's a minus sign out here that I'm going to have to distribute to both terms. So I'm really going to end up with 2x minus 2x, because that's negative 2x. And when you distribute it over, that'll be a minus 6 equals 2. No more parentheses, but now you could combine the positive 2x with the negative 2x. Something weird happens, they cancel out. So you end up with negative 6 equals 2, which means that that's impossible. Negative 6 can never equal 2. So what do we say? No solution. No solution is the answer to number 9. How about this guy? Number 17. Would you use substitution or linear combinations? Neither. Neither. Graphing is the best. They both have the same b value. So if you take a moment to think about that, on a graph, on the x-axis, y-axis, the b values of negative 5, negative 1, 2, 3, 4, 5, they both cross right there at negative 5. So the top equation, it's going to go up 2 over 3. You connect the dots, there's your line. The bottom equation is going to go down 1 over 2, connect the dots, there's your line. They still cross at that b value. So visually, you already know that the answer is going to be the coordinate 0, negative 5, just by knowing that they're both in slope-intercept form and they both have the same exact b value, so they both cross the y-axis at the same exact point, which means that they both have the shared coordinate 0, negative 5. Now, yes, you could substitute one into the other. You could change it to standard form both by multiplying to get rid of the fractions and use a linear combinations or elimination method. But at the end of it all, you're going to get the same exact answer, 0, negative 5.